Welcome to the Driller Newscast. It's 2026. This is the first episode of the year, episode 156. I'm your host, Brock Yordy, and welcome to the new year. Yes, we're a few weeks in, and lots is going on. We have groundwater conferences happening across the country in each state. I was just at Colorado, and the hot button topic was geothermal. Our feature this week will be with Dan Surgeson, a design engineer in geothermal for Salas O'Brien. He's got great insight in how we all can work together. He loves working with the drilling industry. And that's exactly what I want to talk to before we jump into this great feature. And that's, how do we work together? As I was at the Colorado show, I presented on the similarities and the differences in a geothermal borehole and water well. And this is right now the beautiful time to join better together, finding our way as IGSPA, groundwater, geothermal professionals, National Groundwater Association, water well drillers, and geothermal professionals, as we look at the Geothermal Drilling Association and all of the great associations. Like, I love the way New York Geo Association and the Empire State Water Well Drillers work so well together, because policy making, regulation, and how we all work together is crucial. And as I presented in Colorado, the discussion started. Should we allow geothermal drillers to be part of our association? That was a comment made from a member, not from the president, not from the board, but from a member. And the answer is a no-brainer. Absolutely. Every one of us that drills a hole, as we intersect groundwater, we become groundwater professionals. We should be working together, not legislating against each other. As we look at past presidents of the National Groundwater Association, many of them, most of them, have diversified their business into geothermal drilling for closed loop, for open loop, for standing column, for dynamic closed loop. Now we're seeing the professionals out of Minnesota and the Spaniards all having dynamic closed loop systems that take 12-inch water wells, install a heat exchanger into them, and have a dynamic closed loop. That fits right into your business. That is your wheelhouse, groundwater professionals, as we think about sizing, screening, and pumping appropriately. But we can work together, we can legislate together, we can build policy. Look at what Georgia did to be able to have a water well if you have more than 1 acre of land within city limits. Huge legislation push. And Georgia and the geothermal associations like Geo Exchange, who is on the boots on the ground in DC doing our policy making, they all work together as Ryan and Tucker find time to find common ground and advocate for our industry. Because the opposite is like the email I just got from a Great Lakes state that said, listen, our guidelines and best practices are on hold as we make a decision if the groundwater and environmental division should continue to regulate this, or if it should go to the mineral and oil and gas division. And I'll tell you what, oil and gas industry, we are brothers and sisters. We work together. Power generation, hydrothermal, dry hot rock, 1,500 horsepower, 2,000, 2,500 horsepower rigs. Yes, we need all that oil and gas technology. And as we are drilling professionals, we love the advancements in technology. But I'm just going to say it right here. Hey, stay on your side of the fence when it comes to how we're going to design and do policy making, because this is ridiculous to think that suddenly the only way a geothermal permit can be permitted is through an oil and gas division or advocacy that says that we need this massive backyard. You're going to bottleneck the industry. Seeing it happen in Ann Arbor, Michigan. There's plenty of places that I'll tell you what, as we look at the universities across the country that have adopted mud rotary, air rotary, sonic, understand the environmental impacts, understand the production of water, understand what we're intersecting. We all need to mitigate the risk. We need to have the well control plan in place. But this is like my son would say, don't yuck my yum. It's time for us to start thinking about, is 1,500 foot holes appropriate? Especially when I see great geothermal drilling professionals, water well companies that have diversified, able to drill 12 and 1,500 foot a day, and that being 2 to 3 holes, as we look at depths from 300 to 500 to 850 to even 1,000. Let's tool up. Let's do this efficiently. Let's work together. And that's what it comes back to. As Colorado groundwater came together and they brought the geothermal professionals in and they all ascended on Denver, it was a great discussion. We saw Terry Proffer there giving some great insight. Kevin with the groundwater resource division having great discussions. We need to stop thinking that there's no way we can do this and do it safely, because we are doing it safely across the country. We need to trust in the process and be collaborative. Now I want to jump into this great discussion with Dan and his journey from intern to engineer and working with drillers and finding time to be muddy in the field and learning a lot and collaborating, because that's what it's going to take. Us taking our tribal self-taught knowledge along with our technical knowledge and applying it with the engineered specifications, getting the client and developer involved, and making sure we're not a nuisance to the neighbors around us as we get into much dense urban areas as we're drilling these geo exchange holes. I hope you enjoy. For this week's feature, we have another geothermal professional that we'd love to get into how the heck he got into this career, what he was doing beforehand. And so I want to introduce you all to Dan Surgeson. Dan, go ahead and introduce yourself, what your role is, what you're up to.
Sure. Yeah, thanks for having me, Brock. Appreciate it. Yeah, Dan Surgeson. I'm a Geothermal Discipline Manager for Salas O'Brien. I've been in the industry since 2013, since I graduated college, and currently I focus mostly on geothermal projects. I started in a few different projects at a small firm, but today mostly geo, and I hold a engineering license in New York State, as well as the credentials, HPA's credentials, the Certified Geothermal Designer and Certified Geothermal Inspector.
All right, so you went off to college. What did you study?
I went to Drexel University, started mechanical engineering, and then, 70% of the way through was pretty tired of learning about like forces on a gear tooth and stuff. Very dry, very dry classes. So that was when I switched from mechanical engineering to actually environmental and civil engineering. So that's my degree.
Excellent. And then right out of college, you jumped right into doing environmental and civil engineering?
Sort of. I did, Drexel has a weird quarter schedule. So after college, even after an engineering degree, I took a little break. I didn't run right into work like a lot of my friends did. I enjoyed the summer. And then, I basically took the first engineering consulting job within a couple miles from where I went to middle school. It's literally on the same road. Small firm. It was recommended by friends and family. I knew some of the people. They had great reputation out in Long Island, New York. And yeah, I applied and was interviewed pretty quickly. And they asked me about experience I had. Drexel did co-op programs, which was, awesome throughout college. But basically, they hired me because of an internship I had. It was for CDM before they became CDM Smith, when I was maybe 20 years old. And so this small firm hired me right out of college because of that experience that was around. We had a lot of like EPA contracts. It was only a 6-month internship. But I learned a lot about, sampling for water quality, and we were mapping plumes. I was running around even at night, with those low flow sampling pumps, putting them in PVC casing and pumping water up. And it was fun. I liked it. It wasn't quite, it was engineering work, but I enjoyed a lot of the running around to different sites, talking to drillers. That was my first experience, as a young 20-year-old, whatever. And so this first job out of college, they saw that and they were like, we need to hire you because we have an open loop system that they were just designing in Long Island, New York. 12 wells, three supply, nine diffusion, 3,600 GPM, which, it didn't mean anything to me at the time. I was like, huh, this sounds cool. But next thing I knew, I got the job in October of 2013 and was essentially working with the driller for a year. Like I would come into the office randomly, like, you know, if the driller couldn't work that day, if it was like absolutely too cold, whatever. So I didn't really get to know my coworkers because I was literally like the drillers were my coworkers for that project. Um, so yeah, that was my start out in Long Island on open loop systems, and we did get into being a small firm. They would take on a lot of work, and they had a good reputation with the hydrogeology of Long Island, which is mostly sand and gravel separated by clay. So God, I know a lot about the aquifers all over Long Island and, New York City, where I've spent most of my life. But it was awesome. I got exposure to how to design drinking water wells, wells for golf courses, golf courses everywhere, and Long Island especially. A lot of remediation projects where, contamination, you got to design something to clean it up, pump and treat, all that kind of stuff. A lot of stuff you can't see, right? Everything that's in the ground. So I worked with a lot of geologists, environmental remediation designers, and the reputation was built up while I was there. I think I was there 9 years, but they got a lot of cool projects too. I mean, they always did, but I guess specifically geo. We did the Obama Public Library in Chicago that you're familiar with, and
Yes, I am.
yeah, yeah, we could talk about that one a bit if you want. I basically designed the geo side with this firm, and then I left in 2021, I think when they were just about to drill it. So I've only heard about it since through people like you or other drillers. Huh.
It's so wild. Our industry, the applying engineered specifications to tribal drilling knowledge is a big piece. And as I've interacted with you and been on some panels with you throughout the geothermal industry, I've always enjoyed our conversations. And I had no idea you had a groundwater background. And I think it's a missing link often in our design process, in our engineering when we look at mechanical and this whole side, because yes, a CDM Smith, a Stantec, a Jacobs, they do a lot of large municipal water wells and that type of stuff. And then you look at Salas as being like one of the biggest geothermal designers out there. And you guys have the same chops as well. And from a remediation standpoint, heck, you would have been in college when I was in college, which would have been 7, 8 years before you. PFAS was an emerging contaminant along with some of the Gen X. And then you would have been in the middle of it. And as you came out, was like starting to define. So there's just such a beautiful correlation between groundwater protection, aquifers, and what we need to build for elegant designs for geothermal. So that's very cool.
Yeah, yeah, no, it's awesome. And I mean, I'm not so familiar with, say, Midwest geology, I should just say geology outside of New York. I mean, I know a little bit to be dangerous, and you could always look up maps and stuff, but Long Island feels like sort of like a they used to call it a sandbox, right? The old boss I used to like, oh, it's a big sandbox, it's a layer cake, he would always say. Separate, the icing is the clay. You have the three cake layers of different thicknesses, and you could only go into the first two because the Lloyd aquifer is the lowest. It's only uh accessible to like coastal communities because of just the way basically glaciers melted millions of years ago, right? So on Long Island you hear avoid the Lloyd. That's a big thing people like to say, but it's valid, right? I mean, only certain areas have access to that one aquifer. So it's kind of, they look at the Lloyd as like the reserve, pristine drinking water for Long Island. And typically you're only allowed to drill into the upper two. The Magathie is the middle one, and the upper glacial is the one closest to surface. But, you know, as you know, that's where anything you dump in the ground contamination wise will eventually get there. And it's going to get to the shallower aquifers first. So I did learn without really knowing what I was learning at the time. Like I kind of just faced it, was interested with the diverse projects we did, and yeah, came out with a pretty good understanding. Like the Venn diagram overlaps between the drilling and water protection and sustainability. Like I somehow have gotten right into the middle of that Venn diagram. So yeah, it's been an awesome career so far, even though it's been 13 years, not getting any younger.
That's a long time, especially um, you know, the pieces you've gotten to see. I think what's neat here is uh, getting to work with drillers right out of the gate, is either a baptism by fire and you excel at it, or you maybe get shoved back into mechanical engineering because you have this moment of like, wait, no, this isn't, I'm supposed to be in a room with peers and books, and now I need to translate when they say, well, it depends.
Yes. Yeah, I knew I always wanted to do engineering. My grandpa was an engineer. But then I also had uncles that were in construction management. So I had, I mean, you could boil it down to like white collar and blue collar, I guess. And I mean, engineering, people think, oh, white collar, that guy's never seen the outside world. He's chained to a desk, right? Like you said, with textbooks and, slide rules and stuff. So I knew I didn't want just that. I do like that. So I did, like I had said, I was that first job out of college, I had no choice really. I was basically with the driller. Fortunately, he was a really nice guy, mom and pop type shop. It was just him and a couple other employees. We were drilling reverse rotary, so just using water to keep the hole open, and we had to abide by Suffolk County Water Authority's well drilling rules. A lot of, plus DEC and all that stuff. So I learned a lot, but I feel like I learned the most just from spending that time with the driller. And understanding what's even possible, right? Like how big is the hole? How big does that borehole get based on the drill bit size? How straight is it? How do you keep it open? How do you prevent cave-ins? All that kind of stuff that probably keep drillers up at night, right? Where they know they have to protect their equipment and obviously make money to stay in business. So it's given me that early involvement, even dating back to college, gave me a real insight and appreciation to what drillers do. So I always knew, you know, that in addition to engineering and being a white collar engineer, I guess, I wanted to get some blue on there by always consulting with the drillers, and even construction managers to an extent, but especially the drillers because we need them to do this, right? And people love to not even contact them until it's too late, right? Like you put out an engineer, hopefully not me, but an engineer could put drawings and specs out without consulting a driller. Maybe they don't need to, but if they're like on the younger side, maybe they don't have so much experience, they could put documents out and then they may not get bids back because they're too stringent, right? Or because they didn't consult with a driller, maybe they needed a 1,200-foot borehole and local drillers could only drill to 500, or maybe there's natural gas at 600 or something like that, right? So, yeah, I've really just come to appreciate drilling in general, but the constant communication as a designer, and even, seeing them work like that experience I had as a right out of college kind of guy, that has made me a much better designer. The engagement and actually seeing it. And that might not be, available to people today as much. Like I almost feel like I got lucky to an extent, but um, I think I just kept kind of following that direction, right? I mean, you have choices every day, right? And I would always choose to, oh, you need me to go watch a driller, or you need me to call three drillers to get their equipment stuff, their line of equipment and how they would do this. Like I would always go that direction because I always, it's nice to understand how to design it so it will work and perform. That's one part of the equation. But the other part that's commonly overlooked is, how's the guy going to build it and how long will it take and what are the risks and how do we minimize the risk as a team as opposed to they get a big surprise in those documents that you just sent out without, really consulting with the guys building it.
That's such great insight, and it is scary. Um, on the same note, like if young drillers could go and spend some time with the right engineer, we would have less of a divide. But it very much, the same time you spent in university, that young individual, goes through the ranks of, success and failure. And, drilling is half art, half science, with some physics. But there's a language barrier of you talked about the layer cake, and every driller that will listen to this will nod and be like, this is an engineer I want to spend time with. But at the same time, without this video, if you were to walk into a big drilling conference and say, I've been in the field with you, I've been muddy, I've been cold, I've been there when we couldn't get to total depth and we had to do a bit trip, your age, they go, sure. When
Yeah,
would you have time?
right. Yeah, no, I mean, that's something even to this day, having the experience I have now, but going back, like I've had those weird moments where I would either, ask a question or point something out in fear that they would jump, a driller would jump down my throat like, oh, he doesn't know anything. He just graduated. And it could be true. They could be right in those situations. But I almost had to like remove that hesitation to have the conversations, at least for me, or ask those questions. And in some cases, the drillers, many of them don't want to talk to an engineer because of that, right? So I totally agree. There is like a communication barrier. It is like, I probably never put it into words until now, but like, I'm trying to tear those walls down, right? Because that's what leads to good projects. And that enables us to do them quicker, the driller and the engineer, and even the CM and the owner ultimately of whatever project that is. Like, removing those walls and taking that hesitation and the fear out of the conversation really helps it move along and answers a lot of,
Smoothly.
yeah, yeah. And a lot of those questions, like, we probably have talked about it before, but even, yeah, like specs, right? I mean, that's half of, or, not half of what we do, but drawings and specs, that's a big part of what engineering is. But yeah, we like to, I'm probably a broken record, but we like to speak with those drillers so that they could inform us what they're capable of. We could edit our spec. We could have a conversation like this. Or I go to their offices a lot. I was in a driller's office on Friday going over really early plans for upcoming projects, but, just kind of picking each other's brains before the construction, before things are published, you know, before that, plumber puts a rebar right through that geothermal pipe, like early coordination, how is it all going to go down? I really try to keep those walls down, and it's hard. I mean, I probably do that in my life anyway, regardless of drilling. But like, I don't like to have those barriers, right? So in everything I do, I try to ask those questions. I used to be embarrassed sometimes when I was a fresh college kid, asking, why do we need sand bedding or whatever the questions were at the time. But I guess that's advice to like the younger generation, like don't be afraid to ask quote unquote stupid questions. I do agree there is no stupid question. And I mean, if someone screams at you, I wouldn't take offense to that. And I'm not saying they would be screamed at by a driller. At drillers, engineer, you could be screamed at by an engineer, you could be screamed at by anyone. It's a personality thing. But yeah, I really encourage younger people that want to get into this to try to remove that fear and the embarrassment of just asking questions, of understanding, even in an engineering office, like why do we do it this way? And then people always say, oh, we've always done it this way. I think we've talked about this, where that's usually a reason to like take another hard look at why you've always done it this way, and are there other ways to improve it? So yeah, at least at Salas O'Brien today, that is my like one of my roles or objectives here is to, not necessarily make everything more driller friendly, but like reach some sort of mutual understanding of how we're going to go about this thing
I think
being project.
I think that's a great point, and we're we're in a transition as an industry right now in the geothermal revolution of everything that's happening to water wells are at $10.5 billion worth of revenue for the first time in many years. So our water well drillers are very busy. So we have geothermal drillers, we have foundation drillers, we have construction drillers coming in, but we also have a whole new class of engineers who, as they graduate college, have also been impacted by excessive weather
Hmm.
and climate change and net zero rules that have come across. And so we have a generational shift of where, you know, it's not uncommon from 35 to 45 to be in a senior role right now with having 24-year-olds coming in and realizing that in a drilling or civil construction side, the average age is 55.
Yeah.
And of course, it's scary because of the age gap or the what do you mean you don't understand that? Some of it's the stigma. And so now, as a senior engineer, you have new professionals coming to work with you, right?
Yeah. Yeah. We just, literally a few days ago, I had interviewed an intern. They don't actually graduate for another year and a half or so, but they are very adamant about working in geothermal, working at Salas O'Brien. So they're going to be an intern for us next summer. So I mean, that's another thing we like to hire interns with, a longer time horizon, looking beyond graduation, which I didn't do. I literally just thought life ended after graduating college, and then I graduated and was like, wow, what do I do now? And I mean, that's when I said I got lucky earlier, that's also kind of what I meant too, because I don't know. I mean, sticking through engineering school is hard. There's ups and downs with any degree, I'm sure, but it took a lot of convincing myself, oh, it'll be worth it. Let me get through this. And I did. I'm glad I did. And I got that job and I'm happy to be and grateful to be where I am now. But not every young person will have that trajectory. So yeah, we love to hire interns. I mean, trying to, show them the different paths from a young age, whether it's geothermal or not. And then once they come on full time after graduating, like and it's always a conversation with that individual person, but maybe I'm a broken record, but I love to get them out in the field, right? To introduce them to the drillers, get, mud and graphite all over
It's
their,
fun.
yeah, yeah. And, we're all just people trying to figure this out. It's a business, of course, but it is, you know, like I'm sure graduating now, it's bleak, right? After the pandemic, seeing all the climate change, it's hard to, at least for me, it was hard to identify what you're really passionate about. And sustainability and geothermal kind of fell into my lap, and I've been chasing that thread, and I'm happy I have. So yeah, I would, as far as getting involved as a college graduate, I would take that internship that might not be so glamorous. That's kind of how I got started too. So, not having keeping an open mind is pretty vague, but just having a desire to learn how it actually is assembled. I'm a very visual learner. I mean, I could do the math and the science and calculate stuff, but it is much less fun than seeing, pulling out that water well handbook and figuring something out with, the guy doing it right next to you type of stuff. So I feel like that has shown me like the why, right? Like you get more of, I guess, the more you go in your career, you want to really understand, I mean, what you're passionate about, but also like, why am I doing this? Not only for myself, but for the greater good. So yeah, I just think engaging, having that, breaking those walls down again and just not being nervous of talking to people in the industry in general, but especially the installers, the regulators too. Just having conversations and, not necessarily holding everyone to their word and looking for stuff in writing, like just taking all that away and, getting to know each other, but also aligning your interest, right? I mean, a driller wants it successful, a regulator wants it as code, so do the engineers. I mean, probably the owner wants it done yesterday. There's some things you can't control, but there is a lot of alignment you could do on projects to, remove surprises. There's always surprises in drilling, right? So you can't eliminate surprises, but it's nice to get, kind of buy-in. And I've learned that, I guess, from an early age, and it's hard to describe that, how you do that to a younger person. But yeah, I think just removing hesitation to talk to people in the industry, asking questions, trying to, um, you know, get in the field as much as you can type of thing. Like that's really helped me not only become better at what I do, but just feel more confident in presenting and having further discussions, right? Even like this right now, like 10 years ago, no way. I'd probably be cowering in my science books or something. But today, having the experience, it's really just helped me along the way. And, being able to contribute to the industry and to Salas O'Brien has been super rewarding for, all the stuff that we do.
It's moving so fast, and you being in our most populous city in the country, New York, um, everything that's happening right now, you're absolutely right. We're all trying to get to the same common goal, and the system has to work. Um, and unlike everything that we build that's vertically, you know, straight up, it is hard to describe. We're discovering the unknown together, and we're installing something to a specification that needs to last. So that speed of trust, being able to ask the questions, being able to ask why not, is um, invaluable. And I think it's very cool that you're hiring interns and you get to be an intern. I went from a mom and pop drilling company to college to an internship for Bayreuth Halliburton. I thought I would do the internship for 4 months and go back to dad and grandpa. And instead, 2 months in, they hired me. And it was, wait, so I was in West Michigan in the Midwest, and suddenly I'm seeing the country and the world and like poof, and working with other professionals and languages. And New York right now is a hotbed, is what I'm getting to, is there's all sorts of, you were working on standing column wells, right in the beginning, and or you were talking about dynamic closed loop, but like we're moving so fast in what we need to do for heating and cooling and power generation that how much of your time right now is spent in designing geothermal heating and cooling systems?
Um, I would say most of it, at least half. I mean, I guess I'm a little higher level designer now. I'm not necessarily getting totally into the weeds on designs. And I mean, it's hard for me to not a lot of the time. I'm pretty detailed. And I like to, cross the T's and dot the I's before those drawings and specs ever have eyes on them from an outsider. Um, but yeah, like there's always the nuances, right? I mean, there's those standard details you could use from project to project, whether it's a standing column, which honestly I haven't touched standing column since St. Pat's Cathedral, 10 years ago, 9 years ago. It works, it's great if it's done right. It was there because, titanium everything, basically. And but like every project is different despite the same details you might carry over. But I've been trying to help our younger engineers identify those differentiators from project to project, whether it's closed loop, open loop, standing column, coaxial, whatever. But trying to show them where the issues are going to be during design and then also during construction. What, if you go this way, watch out for this type of thing. It's pretty easy to say right now, but it's a whole nother thing if like I said, we hate surprises on projects, but so much could just be avoided by sort of identifying those hurdles and even identifying yours, the drillers, and the CMs blind spots because you may not know them, but like having the conversations allows you to be like, wait, how are we gonna, if they're gonna drill it, 1,000 feet, and then we're gonna put a building on top of it. What do we do when the drill rig leaves? And before you put the piping in, right? Because that's how it goes a lot in New York. The driller comes with the rig, they put in all their verticals, regardless of the type of heat exchanger, and then they're off site for 6 months sometimes. We got to make sure that the ground component's protected. Thermally, it's not going to freeze, the obvious stuff, but then also that when the piling contractor comes in or they dig a footing or whatever, like they're not going to bash into that loop. And if they do, how are we going to fix it, right? You need the contingency plan. So, yeah, this is a long answer to your question of my design work, but a lot of it's focused on that now, kind of guiding our younger engineers and also at a high level, kind of pointing out, trying to find those blind spots with that specific group of people putting the project together. And then, talking about them. How do we minimize the risk? What if we collide into another borehole, right? That's another thing that happens on these postage stamp size sites that we work on, that we're building on top of, right? So, it's all possible. It's just, it requires a lot of communication, like anything in life, but sometimes the communication here in the industry could be broken, whether it's a competitor or, maybe someone, like you said, like the average age of CMs is 55. Like my uncles that are construction manager, I mean, they're way retired now, but I remember when I graduated college, I was like, oh, I'm getting into geothermal. And they're like, oh, like steam generation? I was like, no, actually, we drill a hole, we put a loop in, we grout it, and that provides heating and cooling and hot water. And their minds will be blown just from that. I'm like, wait, haven't you been doing this for 50 years or whatever? So there is a disconnect, right? Like I'm still waiting for the day where a GC or a CM treat, that geothermal bore before they put the piping in and stuff as like a cooling tower, right? Or a boiler. Their conventional stuff that normally would come in late in the project. They'd land that cooling tower on the building, but they would always plan for that day, right? Like to a T, right? The crane shows up here, it comes right off the flatbed, we'll drop it here at 6 a.m. before anyone could notice type of thing. Like I need that same level of care for this, what's providing the same heating and cooling, except, in the geothermal form versus a cooling tower. So yeah, still waiting for that day. It's getting better. It's getting easier with the people, not just the drillers, but more so like the construction managers, the GCs, like they have a lot of experience, for some of them like decades, but this is still kind of a new thing to them. So that's fine. Like they don't need to pretend to know everything. I'm happy to help them and admit that I don't know everything either, but kind of disarming everybody in a project early, if possible, has really paid dividends for, where I am today, but also the success of like projects that I've worked on with a whole team of people.
Thanks, Dan. That was fantastic. Again, let's make sure we're making it to our state groundwater association conferences, that we're making it to our geothermal association conferences. We have New York Geo coming up in March. I'm going to be all over the place in March, Michigan groundwater. I was just in Colorado a few weeks ago. There's so much going on. I'll be in Baltimore for a thermal energy summit. And then we have IGSBA in April. There's so much going on here that we need to be involved in. We need to be advocating together. And you can see just in this first half of this interview, because we had so much to talk about, we just had to continue. So we'll have a quick second half next week, and then we will continue to kick on the policy, the news, and the industry information that we need to be better professionals together. Have a great week. Check out thedriller.com. Check out Brock and Dave podcast. We have a live National Groundwater podcast that has dropped. We have several from the National Groundwater Association conference floor. There was so much talked about. Catch up on the podcast. Enjoy. Have a great week. Be safe. Let's start this first quarter off nice and strong. and check in on your people, because there's all kinds of goofy things going out there, and their feelings and what's happening within our country matter to us as business professionals, as friends, as family members, and we need to make sure that we are strong and united together. Cheers, everybody.